kiddos, we're going to be talking about exponential functions for the next couple of days. We began graphing those before we got out. We looked at growth and decay and how to put them on the coordinate plane. You're going to need a calculator to do some of these problems. So if you don't have one at home or you don't like using the one on your phone, you can actually go to www.desmos.com, and on Desmos, when you get to the original screen, this right here is a graphing calculator option. You really don't need that for these problems we're going to be doing. What you want to do is you want to scroll right here and look at for function and scientific, and go ahead and click on the scientific part, and then right here is your calculator, okay? It'll do almost everything that the calculators here at school will do. So again, that's www.desmos.com. Now, let's go ahead and get started with our lesson. If you remember before we left, if you don't, it's fine. We're going to go right back over it. An exponential function, its generic form is y equals, or f of x equals, a times b to the x. Let's remember what those variables stand for. Now, a is your initial amount. An initial amount is how many that you start with. It doesn't matter if you're doing growth or if you're doing decay. A is how much you start with. Now B, this is going to be your growth or your decay factor. Okay? So if you're dealing with exponential growth, what you will do is you will replace B with 1 plus R. Okay? Well, what is R? R is your rate. It's going to be a percent. Okay? Now, if you're dealing with exponential decay, you are going to replace B with 1 minus R, which again will be 1 minus your rate, or 1 minus your percent as a decimal, okay? So looking through this one more time, A is going to be your initial amount. That's how much you start with. B is going to be your growth or your decay factor, depending on what type of problem you're solving. If you are dealing with exponential growth, you are going to replace your B with 1 plus your percent or rate as a decimal. If you're dealing with exponential decay, you are going to replace B with 1 minus your percent as a decimal. Now, the reason being is that when we have exponential growth, our B value should be greater than 1. In order to make that happen, we have to do 1 plus our rate, and that'll make our value greater than 1. In order to have exponential decay, our B value should be in between 0 and 1. So in order to make that happen, we have to do 1 minus our rate as a decimal. I'll give you just a moment to look over this and write down anything in your notes that you need to. Remember, you can pause these videos at any time so that you can write things down. Now, on your Haiku page, I have a worksheet downloaded on there for you. If you can download that and print it out, it'll help you a lot. But if you can't, you can just pull it up and you can look at it as we're going through these assignments, because I'm going to have it up here for you as well. So I'm going to now click over here. Okay, and this is going to be my first worksheet. You'll see that we're going to start with exponential growth. So I'm going to fill in all this information for you so that you'll have it for your notes, but it's exactly what I just talked about on this other screen, okay? So let me go ahead and click on the pen. Now the formula, if you will remember, the basic formula is A times B to the X. But if I'm talking about exponential growth, what I just told you before is I can replace B with 1 plus R, which again is my percentage rate, my rate of growth. And then I'm going to replace the exponent x with t because we're going to be talking about time. Now, x doesn't always have to be time, but in most all problems that we're going to be doing, your x value is going to be a time unit. So filling this over here, remember A is your initial amount. R is your growth rate, because we're talking about exponential growth in this problem, and T is just going to be your time. Okay? So let's look at problem number 1. Let's figure out what our A, our R, and our T are going to be. Let's plug it into our formula and see what we can come up with here. Okay? So the original value of an investment, remember an investment is something that you put money into in order to hopefully grow more money. The original value of an investment is $1,400. It tells you right here that this is the original value. Okay, so shouldn't that be A, our initial amount? I think so too. So I'm going to write down right here that A is going to be $1,400. Now the value, what does the value do? This is very important. The value increases. That right there lets me know that I'm dealing with exponential growth. So yay, our money's going to grow instead of decay. So we're going to have an increase of 9%. 9% is my rate. But you know, I know, we all know, we can't use 9% when we work out our problem. So what we have to do is we have to take that 9% and change it out of its percent form into a decimal form. So if I have 9% as a decimal, remember, or as a percent, sorry, the decimal is located behind the 9. So in order to change it from a percent into a decimal, I have to move the decimal point 2 places to the left. You see this little empty spot right here? I'm going to replace that empty spot with a 0. So that tells me my rate is 9%, which is also 0.09 in decimal form. So let's finish reading the problem. The value increases by 9% each year. So our time has to be in years. If your percent or your rate is in years, then your time needs to be in years. Those two things have got to equal one another. So use an exponential growth function to find the value of the investment after 25 years. So my time is going to be 25 years. So once again, notice your percent is in terms of years, and now your time is also in terms of years. Those two need to be in the same format. Years and years, months and months, days and days, whatever the case may be. All right, so let's plug into our formula. Since we know what A, T, and R are now, we can plug it in. So I'm going to go ahead and use y equals instead of f of x equals just to save a little bit of space here. So I have y is equal to, remember the first thing is your initial amount. What did you start with? We started with $1,400. Since we're doing exponential growth, because you'll see it increases, so that's exponential growth, we'll do 1 plus our percent as a decimal. So 1 plus 0.09. Now, my exponent, my x or my t, is going to be my time. My time is in 25 years. Okay? Now, 1 plus 0.09, we know that's 1.09. You can replace that when you put it in your calculator, or you can plug it in your calculator just like this. Now, let's go over here and let's plug in. Now, the first thing that we had was our initial amount, which was $1,400. And then we are going to put our parenthesis here, 1.09, that's my 1 plus 0.09 inside the parenthesis. And then I'm going to raise it up to the 25th power. All right, so when I plug this in, this is the amount that I'm going to get, $12,072, and then I've got 5 decimal places behind my decimal point. If this is money, we know that we're not going to go out 5 decimal places, are we? We are actually only going to go out to 2 decimal places. So I've got 0.31. Now look behind the 1. Do you see this 2? That tells me my money is not going to round up. So I end up with $12,072.31. Okay, so this is your first jump into an exponential growth function. Okay, now the next thing that I'm going to do is I'm going to do number 2 with you, and then I want you to pause the video, and I'm going to let you do number 3 on your own. So let's look at number 2. The cost of tuition at a college is $12,000 and is what? Increasing. So since it's increasing, we know that once again we're dealing with exponential growth. And it's increasing at a rate of 6% each year. So that tells me my time has got to be in terms of years. So use an exponential function to find the tuition cost after 4 years. All right, so A is going to be my initial amount. The initial amount, or the college tuition amount right now, is $12,000. That's where it's starting. Okay, and then it tells us that we have a rate of 6%. Now, to change 6% from a percent to a decimal, remember, it's a whole number, so it's going to have a decimal located at the end. Move it 2 places to the left, and wherever you see a blank spot, that's where you put a 0. So, my rate is 6%, which is also 0.06. My time, which is T, is going to be 4 years. Since my rate, 6%, is in years, and my time is in years, I'm in great shape. So I'm ready to plug into the formula. So looking at the formula for exponential growth,